Whose life would be better if you knew more C++? Whose life would be better if your coworkers knew more C++? Let's get started.
Welcome. This is Undefined Behavior, and this talk is part of the Back to the Basics track. But we are going to progress all the way through this talk. For those of you that don't know, my name is Barbara, and this is Ansel. We'd like to welcome you here, and we'd like to welcome our online attendees as well. If you're online and you have any questions, please feel free to ask them anytime. We have a moderator here who will read the questions for us, and we will take them as we go. No reason to wait till the end of the talk. So in order to understand undefined behavior, we really need to talk about definitions. We need to make sure that we're speaking the same language. And we need to establish this right up front. We also need to examine some questions, like, is undefined behavior just another kind of error? And if it is, how do we want to handle it? And is undefined behavior something we can use to our advantage? Can we leverage undefined behavior? Is that acceptable? So again, we need to establish the rules and the boundaries of undefined behavior. We're also going to show several examples where we get to take a look at code and decide, could this be undefined behavior? So we're going to have some participation during the talk. And again, feel free to ask questions if you're not sure if something is undefined behavior. Before we get started, just a very brief introduction. Ansel and I are the co-founders of the CppCon project. CppCon is a set of cross-platform GUI libraries. It's written in C++. It uses C++, modern C++. If you're writing in C++, which I'm going to make the assumption that you are, that's why you're here, then we are missing slides apparently. I'm sorry to interrupt the camera people. We are apparently missing slide feedback. So in CppCon, you can use it in any C++ application. There are multiple libraries. There's 12 different libraries that you can use. We're also the developers of CS String, CS Signal, and CS libguarded. The one I really want to point out is CS String. If you use UTF-8, or would like to use UTF-8 and UTF-16, CS String is a library you really want to consider. It is basically a drop-in replacement for STD string. And you can have UTF-8 support today. You don't need to wait. And again, these are libraries which you can have. Oh, we are taking care of our feedback. Thank you so much for bearing with us. We are activating what we need to see on the slides. Thank you. So again, these three libraries of CS String, Signal, and libguarded, they're standalone libraries. So if you're saying, well, I can't really use CppCon, it has too much, or it's not what I need, these are libraries you can just link with. Everything we do is open source. Everything is available on GitHub. Take a look at the source code. If you're looking for an open source project, please consider contributing or being part of our team. You can use them royalty-free. There's no cost to using our code.
So why are we here talking about undefined behavior when there's been so many talks about this subject? Well, as part of preparing for this, we took a look around at some of the ideas that people are expressing about undefined behavior. And so we went to the source of all knowledge for C++ programmers, Stack Overflow. And we looked at some comments and thoughts that people were saying, like, well, undefined behavior is no big deal. I find it in my code reviews. Or debugging it takes a little bit of practice and then you're fine.
You can just do, if your testing is really good, then you'll catch everything in your unit tests. No big deal. Undefined behavior, it's just not that complicated. That's what's on Stack Overflow. There's also comments on Stack Overflow saying things like, they really want to get rid of undefined behavior. The standards committee is working really hard. They don't like undefined behavior. It was an accident. They didn't mean to forget about it. Oops, we just kind of forgot. So this is what's on Stack Overflow. The exciting one is experienced developers. They know the good undefined behavior and the bad undefined behavior. So as long as you avoid the bad undefined behavior, you're fine.
Now, what the standard actually says about undefined behavior is a correct program must be free of undefined behavior. So that means by definition, if your program has undefined behavior, it is not correct. And do we really want to be writing incorrect programs? I don't. We look at this a little differently than a lot of other people who speak about undefined behavior. A lot of the people who give this talk, or talks on this subject, are compiler designers. And they're fascinating talks about the internals of compilers and how they understand their code. But what we want to emphasize is the information that's useful to us as application programmers. Because we don't want to just make undefined behavior this fun theoretical discussion and talk about optimization and performance. We want to look at the fundamentals of what it means in our everyday life as programmers. As application developers, our objective is to write code that has no undefined behavior, and understanding how to avoid it is mandatory.
So let's start out right away with an example. Here's 2 lines of code. We have an std vector, and it's a vector of strings. We're using the variable name names. Okay, I'm doing a code review. That looks fine. I can use the word names. The next line of code. We're taking names and we're initializing it, assigning values using an initializer list. So as I'm looking at this, I want to ask, is this undefined behavior in any way, shape, or form? And I look at this and it's like, well, these are strings. I know what a tiger is, a horse, an ostrich. A geronook, in case you're not familiar, it is this long-necked antelope, and it means giraffe-necked in Somalia. It's kind of an odd-looking animal. And then we have a jodenki. Now, if you're not familiar with the jodenki, it's a 3-legged animal, really interesting, and it has a vegetarian diet.
Wait a minute.
What?
No.
What?
A yodanki charges off of USB and it runs at about 3 gigahertz.
No, it's a jodenki, and it's an animal. Remember? Vegetarian, 3 legs, kind of hops.
No, we bought the yodanki. I have one on my desk. You saw the purchase order.
There is no way it's on your desk. It's a jodenki.
No, that's not how it's pronounced.
What do you, wait, sorry. I wrote this slide. You saw it.
You said this was a list of animal names. It's not.
But it is a list of strings.
Okay, yeah, they're valid strings, but they're not all names of animals.
But jodenki's an animal.
Wait
a sec.
Sorry. We need a way to settle this. We need to look at some standard.
Well, but it's not UB in C++, so I don't know what standard to look at.
Well, the standard for what words mean in American English is Webster's Dictionary.
You're right. Webster's. This isn't the C++ standard, but we need to look at Webster's. There's about 500,000 words in Webster's, and there's about 1,000 that are added every year. It turns out jodenki's not in there. It's not a word.
Neither is yodanki.
Jodenki. Let's get it right. Jodenki. I've been trying to teach it to him. It's not a valid word. This is undefined behavior. And there's no way to know how to pronounce it. And there's no idea whether it's a USB device or a 3-legged animal.
So any sentence you use this word in, you can't really ask the question. I mean, if we say feeding a jodenki or a yodanki too much chocolate isn't harmful, you can't even answer that yes or no because it doesn't mean anything.
I do like my jodenki connects over USB 3 and Wi-Fi. The problem is, because Jodenki doesn't mean anything, although it is just characters strung together, the entire sentence has no meaning. You can't reason through what it means at all.
So let's take this idea of definitions and start building a definition of the term undefined behavior. And let's look at what undefined means. Well, the dictionary says it's not clearly or precisely shown, described, or limited.
And behavior, this is the way in which something functions or operates. So when you're writing a story, and maybe fiction, it would be okay to use nonsensical words. That's not software. And we do know that authors break these rules all the time. And you can infer what it might mean. And I like this sentence. A Wookiee, a Klingon, and a Hobbit walk into a bar. I'd like to know the rest of the story. I have no idea what they're going to order. I have no idea what they're eating or drinking. But now I'm intrigued. But that's fiction. That isn't C++, and it isn't source code. This sentence and this story is mythical. That's not what we write.
So if we look at the phrase, behavior which is undefined, which the standard uses a few times, well, the English definition for this would be something which does not function as described. This is an interesting idea. So if you try to play a guitar with missing strings, is that functioning as described by the word guitar?
It might make a sound. If, depending on which strings are missing, you might get something musical out of it. But it is not functioning as a guitar as we know. And there are other examples here about a keyboard being a monitor. I think we're pretty much clear that a keyboard's a keyboard and a monitor is a monitor. So if you try to put a sentence like this together, again, you're in undefined behavior.
Now, a lot of times people say, well, list all the undefined behavior. I want to know what undefined behavior there is. Well, that's equivalent to saying how many things you can say aren't words. The problem is we have a list of words. It's the dictionary. We don't have a list of what isn't a word because it would be infinite.
I think we found that the longest word we could find was about 39 characters. So if you want to start doing the math of 2-letter words, 3-letter words, 4-letter words, using 26 letters in English, that is a lot of words. So there is no dictionary, there is no definition of what's undefined. So hopefully we've dispelled that myth that we can actually list everything in C++ that is undefined. We can describe subsets. We can describe ideas of what you're looking for. But we can't really come up with a definitive list of what is undefined. And I know that bothers some people, but that's where we're starting from. That is a definition.
It's far better to make it a habit to only use words that are found in the dictionary. Then you don't have to ask this question as often. So let's look at another example. What happens if you read off the end of a vector of t? Well, there's a couple of things that could happen. It could return some valid value of type t. It might return some value that isn't a valid instance of t. The program might crash. The read could just be optimized away by the compiler. Any of these things could happen because, according to the C++ standard, reading past the end of a vector is undefined behavior. So let's take a second to walk through what the C++ definition of the various kinds of behavior are, so that we understand what it means to say this is undefined behavior.
So the first definition we need to look at is defined behavior. And this is specified in the C++ standard. So if you were to see an expression like this of int sum 17 plus 8, that has a defined value. If it does not, please report that to your compiler. These people need to know. That is defined behavior, and it should not only have the right value, it should be the right value every single time. So that is what defined behavior is. If you're using a printf, and It doesn't print that exact string. Welcome to CppCon 2021. File a bug report. Because these are things that are defined, which means they work a specific way.
Then there's implementation-defined behavior, which is code that could have multiple meanings, and the compiler, or possibly the platform, needs to pick one and document the choice. So here we're saying, is the size of an int less than the size of a long? The standard doesn't say whether this is true or false, but it's a perfectly reasonable question to ask, and for a given platform, it will have a consistent answer, because int and long don't change size.
Then we have unspecified behavior. And this is code which could have multiple meanings. And the compiler is allowed to choose one at random.
So here we're comparing string literals, and although it's not always obvious that string literals are in fact arrays, what this is actually doing is comparing the address of two arrays that were created by the compiler. And the question is, do these two arrays actually live at the same address? The compiler can put them together because they have the same contents. It's not required to. This is completely unpredictable. It's up to what the optimizer did, or maybe the dynamic linker when your program was starting. It could change at random. All you know is that this if statement is either true or false. But there's no further logic you can apply to that. It's completely random.
And this is the type of code that we see in code reviews. And people aren't aware that since it's unspecified, which does not make it undefined, it's legal code, you can do it, but you may not get the result you think. So this is type of code you still need to be careful about. The next category we have is undefined behavior. And just like Jodenki,
Or Yodonkey.
this is code which has no meaning. No matter how much you try, there's nothing that it means.
So if you invoke the destructor of an object twice, there's nothing in the standard that says your program crashes or anything like that. It just says your code no longer means anything. It's not a C++ program. It's outside the rules of the standard. You're on your own. Doing a bit shift by a negative value, converting a double to a float if the value doesn't fit. These are not operations that cause problems. They are operations that don't mean anything.
So let's take an example. Does this code compile? We see a few heads shaking. Does it compile?
Show of hands. Okay, anybody who says it does not compile? Okay, we have consensus in the room that it does compile.
Does it have UB?
I see a few heads.
We see a few
nod.
hands. People, anybody want to shout out some answers of which lines they think might be undefined behavior? 2 and 5, I'm hearing.
Okay.
If we have anybody online who wants to participate, please feel free to type it in. This is your chance to be strong. And so 2 and 5? 2.
Okay.
We want to make sure everybody gets just a teeny bit of time so that they feel like they can see the example. Oh, now I'm hearing 6. Is
Okay.
so 2.
I think var B doesn't. We don't know what's in it. We can figure it out. It could be.
Okay.
All right. So let's go on and walk through this code.
6 lines of code, and we have some conflicts of what is undefined or not.
So we just did a code review and we got different answers from different participants. This is awesome. Let's see if we can find consensus.
It does compile.
So the first thing is line 2 is undefined behavior. The reasoning is var A contains a null pointer. Initializing it to null pointer is fine. That's not a problem. That's a valid pointer value. But then if we dereference it, you're trying to dereference a null pointer, that's undefined behavior. It's not a crash, it's not a seg fault, it's undefined behavior. Then if we go on, line 3 is fine. We've declared var B, it's uninitialized. Line 4 is okay.
So it's okay to have line 3.
Yeah, line 3 is fine.
Not undefined.
Not undefined at all.
Don't need to initialize.
You don't
Tacky.
Sometimes, but you don't need to initialize things.
Yeah, don't need to initialize.
Line 4 is fine because var B does have an address, even though it's uninitialized. So we can have var A point to var B.
And that's really important. It's really important to understand line 4. Taking the address of var B, even though it's not initialized, it is declared as an int. So you can take the address, and you can assign the address to var A. So if anyone wasn't sure, please speak up, jump up and down, let us know.
And then let's look at the next couple of lines. On line 5, the dereference is valid because var A does point to var B, but once you get there, it's uninitialized memory. And so we're printing the value of uninitialized memory. That's undefined behavior.
So dereferencing var A, that's good. It's the fact that we're doing a less than, taking it to C out. That's not okay.
And then by the exact same logic, line 6 is undefined behavior because we're still printing an uninitialized value. Question?
Why are line 5 and 6 undefined instead of unspecified behavior?
The question was, why are line 5 and 6 undefined instead of unspecified behavior? And that's actually a really deep question, but part of it is, in general, you cannot assume that you can even read a value that has not been initialized. There may be representations that aren't valid representations of that type. And so even though typically there's no invalid integer value, in the standard just says you can't do this.
Just as an example, there are architectures where invalid floating point bit patterns cause hardware traps. And if you read an initialized float, you might get one of those patterns.
The comment from the back was, as an example, there are architectures where there are invalid floating point bit representations that could cause a hardware failure, hardware fault.
We have another question?
Yeah, I'm curious, so if you just output var A without dereferencing, right, it contains the memory address of var B, but that could be like various different things. Is that unspecified or undefined?
So the question was, if we were to just output var A without dereferencing it, I mean, it's an address in memory, so it's unspecified what the actual address would be. Yeah, and you'd have to do some type conversion to get C out to actually print it, but yeah, that's perfectly reasonable to print. It would be unspecified.
Okay.
Yeah.
Yes.
Would it be safe, the way I was thought of unspecified behaviors, there's a finite, fairly small number of alternate behaviors that different platforms exhibit. It could be one of those, like the size of an int, or whether the strings are separately allocated or folded. Whereas with undefined behavior, it's like there's an infinite number of possible behaviors.
The question is whether there's a large set or a small set between unspecified and undefined. And that would depend on the unspecified or the undefined. I'm not even a fan of unspecified behavior because I can't be guaranteed I'm going to use the same compiler, the same version, the same machine, and it could still change.
Well, I'm not a fan of behavior. That's how I sort of distinguish it in my head. The question
Yes.
was, is this undefined or unspecified? I think unspecified has a finite number of possibilities.
Some unspecified behavior is defined with a finite set of possibilities. Some is not. It depends on the exact instance in the standard.
Everybody's okay? Do we have something from online?
Yes, we have a question from online. I'm going to attempt to read the code. So it's A brackets plus plus I equals I. And then the comment is this undefined? So that's, yeah, an array with a referencing plus plus I, assuming I is the index, equal to I. Is this undefined?
Let's hold off on that example
Okay.
for just a couple slides. It's a great question, and thank you for asking it. We are going to address that. I always feel bad doing that, but we should wait.
Yes.
So here's a template.
Let's take a look at the implementation of this template. Does this template have undefined behavior? I'm seeing some people
So we're saying
nodding.
some yeses.
Somebody said
So you're saying
possibly.
yes. Yes?
No?
Wait, what's that? I got to count the yeses
yes.
first. Yes? No? I don't know how to read a template. It's too early in the morning or late at night.
Well, let's look at how you might use
Do you want to venture to say why you think it might be undefined behavior? Do you want to be brave?
Well, from my example from last night, if that works out to be a left shift by more bits than what X is, undefined behavior.
So the question is, what is T1 and T2? Do we have any constraints? Do we have any testing? Now, we do understand this template might not be that valuable in the code. But it is code you could write. So let's take a look at some examples of how we might instantiate this template.
So in the first example, this expands to a left shift by 75 of the number 250, which is indeed undefined behavior, because shifting left by a number larger than the width of an int on your platform will be undefined behavior in this case. The second one is writing the string cat to standard out. So this is an instance of a template which has undefined behavior for certain values of certain data types that it is instantiated with. This makes code kind of hard to reason about. And it's also hard to document, because what are the preconditions for calling this function? Just think about that.
So how is undefined behavior defined by the C++? The result of attempting to execute code whose behavior is not defined within the standard. It's a little redundant, but that's what it is. Now here's the thing. It is the responsibility of programmers to write code which never causes undefined behavior. This is something you intuitively or accidentally agreed to. You're using C++. This is something you agreed to. You won't do it. The compiler expects you not to do it. Your peers expect you not to do it. We write libraries. You expect us not to do it. Hopefully, you would like us not to have you be in our libraries.
What the standard says is your program will operate as written in your source code, only if your code has no undefined behavior. If you have undefined behavior, it stops making any guarantees about how your code will be executed. And this puts you in sort of an undefined state of your program, not just a little bit of undefined behavior.
We said before that we can't give you a definitive list. Anyone who says they can, you can't, because as the standard expands, there may be new things that become undefined. But we did want to put together a list of some of the more common undefined behaviors.
This is like your C++ greatest hits. And there's some of these that are fairly well known in the community. There are some that are kind of surprising, like an infinite loop. It's like a for loop or a while loop that has no termination condition. So there's no way out of it. That has no side effects. And a side effect is something like modifying atomic memory or printing to the screen or doing something that affects the external view of your program. That's actually undefined behavior. And it's surprisingly common to hit this when you're designing multi-threaded programs if you get things just slightly wrong. You can easily create large chunks of your code that have undefined behavior. An erase condition is also undefined behavior. These two taken together make multi-threaded programming in C++ a big challenge.
Do any of these on this slide, anybody have any questions about these of why they're undefined or why a race condition turns into a deadlock really fast? Yes?
Basic question.
Yes.
Why did your compiler catch you if you were trying to modify an object that you declared as common?
The question was, wouldn't your compiler catch you if you're trying to modify an object that was declared as const? Great question. Hold it for about 5 slides and you'll see the answer. But fantastic thinking.
Yes.
So I have a similar question. How would a function that fails to return a value even compile?
Oh, let's see, wait 2.5 slides. We've planted all these questions. They're fantastic. The gentleman over here in the corner. Could you?
So the question was,
so you have a file pointer
related to the use of an object after it's been
Free,
destroyed.
yeah.
If you have a file pointer after you call fclose, is it okay to reuse the file pointer for another file? And yeah, that's perfectly valid because you're then going to call fopen again to create a new file.
We have an online question.
Question from online is, they're just asking if you could please explain infinite loop without side effects.
All right, so
Okay.
I'll take another pass at an infinite loop without side effects. So this is a loop which has no way out. So it might be like while true, or a for loop with a condition that never occurs. And there's nothing in the body of the loop that changes anything outside of your program. You're not writing to some atomic variable, that's a side effect, or writing something to the screen, sending something to a network socket, something like that. I
I'm
think
sorry, we couldn't quite hear the question.
the question was, can you catch these if you have higher warning levels enabled in your compiler? Sometimes. Some compilers will warn about some of these occasionally.
I do want to make sure that we got the online question. So the person is happy. Okay, thank you so much. If not, please chat with us later and we'll go over it again. We're here all day.
Let's go look at our next example. So one of the things which is undefined behavior is if you're doing arithmetic on signed integers and you get a result that's outside the range that can fit in that data type, then you have something called signed integer overflow. That's undefined behavior. This is one the standard says is undefined behavior. So here we have a function that just returns a volume given a length. So we're just taking the input argument and cubing it. This number will get very large very fast. So it's undefined behavior to call this function with a value that causes the result to overflow. Now, unsigned integer arithmetic doesn't overflow according to the standard. It's never undefined behavior. So if we were to change the pass parameter and the return type to unsigned int, all of the undefined behavior would be gone in this function. If it's outside the range that's representable, you'll still get an answer that isn't mathematically correct because the value wrapped around to a smaller number, but you won't have any undefined behavior in your code.
So if you're running code like this and you have input that could be a very large value, which is why we're showing an example of a cube, you may need to actually try to validate what the answer is just to make sure you're within range. And I would actually write this code using an unsigned int, just so that at least I could test it. Because that's the problem. If it's outside, and if you have signed integer, if it's gone in an overflow, you can't test for it. You can't test undefined behavior after it's happened.
So that brings us to our next thought. Undefined behavior is not an error.
In the past, we've referred to this as ubine. It's not an error. It's not treated as an error. It's not considered an error. Because an error is something you can test for.
So I like to think of this as an error, as she said, is something you can test for and then handle. You can take some corrective action. This file didn't open. This socket closed on me, whatever, something like that. You can't handle undefined behavior because by definition, the code that would handle it is running after undefined behavior has occurred, so your program has no meaning. Undefined behavior has to be prevented, not handled. And it's a fundamentally different mindset to look at your code. There's plenty of errors that we deal with on a daily basis. We've all made compile mistakes where we have a missing semicolon or curly braces that are missing. The compiler tells you that's an error. There's code that gives you a runtime error. Like if you call the erase member in std string with an index that's out of range, you get an exception. That's well defined. You can catch it, you can let it terminate your program. There's no undefined behavior there, it's just an error in your code. But undefined behavior is this different kind of thing. So when is it okay?
Is it okay? Is undefined behavior acceptable? I'm sorry?
Only if you're ready for it. Ready for what?
You're not guaranteed a safe shutdown.
You're not
guaranteed that one time you can run and it gives you the right answer, and another time it does shut down. You can't test for it. You can't handle it. You don't know when it's going to happen.
So our opinion is
Never.
undefined behavior is never acceptable.
It's just, that's our rule. That is the rule of, the accepted rule from the standard. And I know there's going to be people who disagree with that, but you can't test for it. So it has to be something that you never do.
Well, I think you have to be very clear on it. It shouldn't happen, actually. It's okay to have code that may exhibit undefined behavior, except that it shouldn't actually happen. But like you could have code that with some inputs would exhibit undefined behavior as long as those inputs never actually get in.
And I respect that opinion, and in our opinion, I can't be guaranteed that that set of data, why would I have undefined behavior that I never get to? That sort of sounds like code.
Every time you write a reference to
Yeah.
P,
Yeah.
it could be null,
It could be
except
null.
you have something else in the code that guarantees it from being null.
Yes.
Star P is potentially undefined behavior.
Yes.
So every time you write star P in your program, you write code that may be undefined behavior.
Maybe.
Or set something else. So yeah, you do write undefined behavior.
It's not undefined behavior
I think-
unless it actually
Unless it doesn't happen. Yes.
I think the way
Hang
to
on.
summarize
Yes.
this discussion is, it is never acceptable to execute undefined behavior.
Yes.
The less undefined behavior opportunities you have in your code, the less likely that is to occur. But a correct program must be free of undefined behavior, meaning it is never actually encountered.
It's never encountered.
So if you know that signed integer overflow is undefined behavior, if you think it's really unlikely to happen with your data set, do you still need to validate the input? And that's a really deep question. It depends on where your input is and how sure you are that it will never be violated and what the consequences are of absolutely anything happening in your program if your assumptions were wrong.
One of the problems with this, not to push and belabor this, but you write this code and you say, no, it's never going to happen. You leave the company, somebody takes over the code, and they don't know your assumption or some of the requirements of the program change. So you really do need to be careful. And it's not enough to just put a comment in that says, this could be undefined behavior under certain conditions.
If you're writing multi-threaded code, you don't want race conditions. They're undefined behavior. But if you just add mutexes everywhere, now you have deadlocks. So you need to think very carefully about your mitigation strategy for undefined behavior based on what it is you're dealing with and the correct way to handle it. This is one that shows up surprisingly often, is accessing an inactive member of a union. So like if you save a float to a member of a union, and then you read from an int data member, that is undefined behavior. That is invalid according to the C++ standard. Some people occasionally used to use this on older compilers, and it usually worked if they wanted to get the bitwise representation of a floating point number on their particular architecture. But it's undefined behavior. The compiler is not required to do anything sane. In many cases, with a modern optimizing compiler, the read of the int might be reordered before you wrote the float, so you read uninitialized data or whatever used to be there. If you do need to actually do this operation, which is fairly rare, the way to do this before C++20 is with a memcopy. And in C++20, we get std bitcast, which does this operation in a well-defined way. Now let's talk a little bit about testing for undefined behavior. We had an experience where there was a developer who came up to us for some advice. He said, I know I have undefined behavior in my code base, but all my unit tests pass. And as soon as I started to take steps to remove the undefined behavior from my code, my unit tests started failing.
He wanted our advice. He was rather confused. So I had undefined behavior, and I have a problem with my tests now that the UB is gone. And he said, now what do I do?
Well, there are a couple of strategies you can take here, but first you have to realize, if your code base has undefined behavior, as soon as you invoke undefined behavior, all bets are off. Your unit tests could be meaningless. They could be returning false positives, false negatives. They have no meaning whatsoever.
He was trying to have the assumption that it was the unit tests that were broken, or if I put the UB back in, then the unit tests will pass. He forgot that the unit tests and the code base that is your code base. It's not just your program. You have to include the unit tests.
So there's a couple of different strategies you can use here. You can put the undefined behavior back in and let your unit tests start passing again. This is not a really good idea. You could just mark the unit test as flaky and say, I'll get to them later. You really need to get to the bottom of a situation like this. Try a different compiler, test with a sanitizer. Figure out why your unit tests were passing and they shouldn't have been. Because you have, at this point, a really critical bug in your code, and you don't even know where it is or what it is. And the reason this happens is because unit tests are calling your application. If your application has undefined behavior, the unit tests just don't mean anything anymore. So since your unit tests are part of your code base, you can't really debug your entire application until you've gotten rid of all undefined behavior from your application and your full unit test suite.
Just so that you know, this was not the answer he wanted. He wanted to actually just either put the UB back in or say what's wrong. The ultimate thing that had happened is the unit tests were always wrong. It's just he didn't know. And he didn't know because of the undefined behavior that was actually in the application.
So this brings up the idea of, what sort of philosophies do people use when they're looking at undefined behavior? And one that we see a lot is, well, my code works on all the current compilers, so it'll probably become part of the standard because everybody agrees. Or, well, it's okay. Just let people do what they're going to do, and then they'll find out that it's wrong in the unit tests. Well, that doesn't work, as we've just seen.
A lot of people believe that undefined behavior should only exist as an opt-in feature. I want lots of speed, so let me opt into the idea of undefined behavior so the compiler can do its magic. This is not an option. You can't opt in or opt out. Again, you're a C++ developer. It is there. The question is, how are you going to handle it?
So our philosophy is, when you're writing code, you have to think about the context of what it is you're doing.
Yes.
If you're reading from a file, you need to handle errors like, did it open? Is it empty? Do I have valid data in the file? If you're writing a multi-threaded application, you're thinking about what data should be atomic or guarded by a mutex. When you're designing a class, you want to look at, what should I mark const? All the time, no matter what code you're writing, you need to be thinking, does this code have any undefined behavior? That's not an extra step you do later, after you write the code. It's always. Now this interacts with the compiler options you use, because when you turn off optimization, the compiler doesn't really look that hard at your code. It just does a literal translation. So most of the time, the undefined behavior does pretty much what you expect. When you turn on optimization, all of a sudden, it starts seeing things like unreachable code can be removed or inlining things. So if you have unexpected results when you turn on optimization, it's a pretty good bet you have undefined behavior somewhere.
So now we've gotten to answer somebody's question. What do I have in this example is I have an example with no return statement. Now it's very easy, I just told you. It actually isn't that easy when you're reading your code. This is a value returning function. We've said we're going to return a bool. There's no return line. This can be caught by UBSAN, but when we did it, we weren't running UBSAN on the code. And this can do anything. It can crash. It could just return true. What was actually happening in our code is the code was just continuing to execute through the assembly. And that's not the code that was necessarily in the source file. It just continued to run and run and run until it found a return statement somewhere later. For some reason, this was very hard for us to debug. But again, UBSAN can pick this up, but it is undefined behavior.
And it is not a compile error.
So here's another example that's very interesting. We're using a Q string. And if you're not familiar with the Q string, just think STD string. Now, what's very interesting, and we want to point out, the Q string that we were using, this particular class, at the time we had this code, there was no null termination. We have that now, but it wasn't there.
So the purpose of this code is to look for everything after the last colon in the string. Treat that as the name of a class. And so we're scanning through. We've got a for loop going from the beginning to the end. And we're looking ahead 2 characters, index +1 and index +2.
As you can see by the comment, what we expected was it to return vector int. What shocked the living daylights out of us is all of the code was elided. It never ran the for loop because of the UB.
And we actually did some work on this to understand the reasoning that the compiler used to justify that. Well, we have a for loop here, and the last 2 iterations of that for loop are always undefined behavior because we're indexing off the end of the string. Well, if the last 2 iterations are always undefined behavior, how do you make sure this code doesn't have any undefined behavior? Well, you assume that the input string is always empty. Then you don't have a last 2 iterations of the for loop. So the effect was not a crash, it was not a seg fault, it just always returned an empty string. This was really frustrating to track down and debug.
Yes?
Yeah, the way I look at this code is, it has defined behavior for an empty string, it has undefined behavior for a non-empty string. The compiler can assume that it's only a defined behavior happens and just replace it with a return.
Yes.
Yeah. So the comment was that this is defined behavior for an empty string and undefined behavior for a non-empty string. So the compiler chooses the behavior that's defined because it knows the other possibility can't happen. You reach the equivalent conclusion. Yeah.
We're going to hold off on a question for just a moment because we want to cover a couple more slides. We're starting to run out of time a teeny bit.
So here's another example that we ran into in some code. Many people know that if you do some operations on a container, they might invalidate iterators. But there's no general rule. You have to verify for each operation that you're doing which exact iterators are invalidated. Now it happens that vector insert potentially invalidates all iterators into the vector because it might have to reallocate. But there's no iterators in this code, so why am I talking about this?
It's a range-based for.
There are iterators in this code, you just can't see them. There are 2 iterators embedded inside the range-based for loop, the current iterator and the end iterator that it tracks. So after you execute line A and we insert an element into the iterator, what's the next element? Both iterators in the range-based for loop are now invalid, so the next iteration of the loop is undefined behavior. It might crash, it might not. It might only crash if it actually moved the memory It's unpredictable.
This next example is with a const cast. Now, what's very interesting with the const cast is the idea is to remove that we've added a const. So on line A, we have declared a string with const. We are calling do thing 8, and we're receiving as a const reference. So line B, we're doing the const cast. That's not the UB. It's line C. And the reason why is because if you initially declare something as a const and then you const cast it, that is just a definition of UB.
This is a really hard kind of undefined behavior to track down because we have all the code here for you on one slide. But you need the combination of line A, declaring it as const, line B, doing a const cast, and line C, actually modifying the reference that you got from const cast. And those 3 lines don't have to be anywhere near each other. They could be spread all the way through your code. So this is a very difficult type of UB to diagnose because none of these lines look wrong in and of themselves. It's only the combination of all 3 on some code path that causes UB.
If we did take out the const on line A, it would no longer be UB. It would be defined behavior.
Because const cast is perfectly legal if the object you're const casting away originally was not const. Here's a fun one. Specializing a type trait, which exists in the STD namespace, is UB. So you can write your own type traits. That's fine. You can name them new things. Type traits is a perfectly reasonable tool to use when writing your code. But in this case, we've decided to specialize the standard type trait called isPointer. We've said, from now on, we're going to say that ints are pointers when you ask the type trait system. This is clearly insane. It's nonsense because ints are not pointers. And this will cause all kinds of havoc in the standard library and any third-party libraries that are using these type traits. So this is an unusual category of undefined behavior. It's undefined behavior that happens at compile time. If you have this in any source file, your entire program from beginning to end is undefined behavior.
We're going to now answer an online question. Are either of these undefined behavior?
We'll give you a moment to think about it.
Lots of silence.
I think they were undefined behavior, but I thought it got specified.
So can you do that? We've made the math fairly simple. Fingers, it all works. On the pre-increment, what kind of result are we going to get? What? Your choice? Anyone want to take a stab at this? var A is 5.
The pre-increment doesn't, like, it increments and returns the new value. Like the post-increment returns the old value, right? So 8 and 5? Am I guessing?
I love this part.
Let's look at the result.
Let's look at it very carefully.
So let's look at the first part of this example first.
It is version dependent.
Before C++11, the first example is undefined behavior because we're doing the pre-increment and the assignment to the same variable. And there's no rule in the standard you can find at that point that says which one happens first. So the behavior is undefined. If you're in a C++11 or newer compiler, it is defined. The increment happens before the assignment, so you get the answer 8.
So the var A is incremented, the addition happens, and then the assignment. In C++11, it has to do with the sequencing and how things can be reordered.
Then if we look at the second part of the example, it's again version dependent, but it took them longer to add the rule to the standard that makes this one defined. So this one only became well-defined in C++17. They finally added the rule that says the post increment occurs before the assignment. So you get the result of 5.
So looking at that second example, if you were in 11, it could take var b, which is 3. It would add the 2, which is 5, assign it. I mean, this is the way it could work. Assign it to var b, then do the post increment, which it would toss. Because it would toss that post increment because there's nothing to do with it. So that would be a possible value, to take 3 and not pre-increment it. So it really depends, not post-incremented. It really depends on the version. So here is code that depends on the version of the standard. The question is, do you want to use this, and do you want to see it in a code review?
And our opinion is no. If you have to be concerned about which version of the standard your code is being executed on, and the result, if you go to an older compiler, is not a compile error, but undefined behavior, your code is not well written. This is something that should not pass code review.
Did we have a question in the back? Yes. I'm sorry? The sequencing of when things happen has nothing to do with whether the arithmetic is associative. It's the sequencing of instructions by the compiler. And the compiler is free to reorder the instructions you have in your code based on a certain set of rules. And so if in 11 it reordered the sequencing and it did these things in a different order, then you would have a different answer. And it would throw out the post increment. That is an option of the compiler. So the sequencing we're talking about is not based on arithmetic, and that is a really good question.
Just to clarify, after 17, is var b 5 or 6?
Var b, in 17, var b is 5.
So it's throwing out the post increment.
So the post increment occurs before the assignment.
So 3 plus 1 is 4 plus 2 is 6.
3 plus 2 is 5.
Right, but var b plus plus.
The
We're showing for 11.
After.
Yeah.
So for var b, if var b is 3 when the statement starts,
3.
you add 2.
Well, incremented.
No, you don't increment. That's
you don't
a post
increment it there.
Okay.
That's a,
Side effects are occurring after the use.
so the
Increment is after the assignment?
the post increment is after the addition.
Okay.
So you add 3
3.
and 2,
That's
then
5.
increment var b,
Yes, after reading the
but
value.
then the value 5 is what goes into var b. So you can look at it as the post increment gets thrown away
Thrown
because
away.
it occurs between the addition and the assignment.
So in C++17 is it 6?
No, it's 5.
But B is 4.
Hmm?
If you were to read B later, it would still be 4.
Yes, if you
Oh,
could
so
read
if you were
B4.
to read b later,
No, it's already.
we're assigning to var b.
Oh, you're assigning to
You're assigning to var b.
So var b ends up with the value 5 if you're in 17.
And then the increment, but it's not assigned back to var b. So the post increment happens and it's tossed. Let's not do this in code.
Let's very briefly look at a few more ideas.
Just
that
really
we have.
quickly, and then
If you believe you have undefined behavior in your code, there's a lot of tools you can use to resolve it, and these grow and get better by the day. All the sanitizers are fantastic. All of these are in Clang. Many of them are in GCC. They're being added to MSVC. Use them. It will help you.
it will show you when you're missing a return statement.
And the last item here is very important. Treat undefined behavior as a critical bug. Treat undefined behavior as every possible bug you could ever have simultaneously, because that's how important it is.
So here's our takeaway. Undefined behavior cannot be treated as an error. And dealing with undefined behavior is not a sometimes thing. It is something you have to do all the time. And it's not a simple topic. We've just briefly gone over some of the ideas. We've exposed some of the places that it gets complicated. Please understand, this is hard. And since it's hard, it's okay to spend a lot of time really looking at it. And again, as we've mentioned, projects can opt out of things like exceptions. You don't have to use them, but you cannot opt out of undefined behavior. And it is your responsibility. You decided to use C++, or your supervisor asked you to use it. You made a contract. You said, I am not going to do undefined behavior. So you want to do your best to make sure that you're testing your code, looking at it, and doing those code reviews. But make sure you're looking at undefined behavior right from the beginning when you're looking at your API. Since this is a back to the basics, we just wanted to point out we have a YouTube channel. These are the videos that we say from our YouTube channel really encapsulate some of the real fundamentals of C++. I encourage you, no matter what level you're at, to watch the first 3 videos. It's always a good refresher course to study data types, value categories, and move semantics. Once you've finished, we have about 65 other videos, light evening. Each one of these videos is about 10 to 15 minutes, and it's us talking and sharing C++. If you're new to some of these topics, these will all be a great introduction for you. Again, we have various aspects of our CopperSpice libraries. Please feel free to come and talk to us. We can share any of the information about the libraries or why you should be using Ansel's CS libguarded library. And if you are not familiar with CopperSpice or you want to understand what can be done, have a look at our kitchen sink demo. I can tell you where the binaries can be found off of our website. We support about 16 different platforms, and Kitchen Sink has about 30 demos in it that'll really show you capabilities.
If you want more information about any of the things we've talked about, visit our website, send us email, contact us on Twitter, or find us in the hall. Thank you.
Thank you so much, and thank you to our online people.